All right, let's just get this out of the way. Orbit multiplier, resurgence, and the Borel geometry of the Feigenbaum cascade in Aether fractals. Yeah, I know, it's a real mouthful. But trust me, we're going to break it all down. What we're actually looking at here is an amazing research paper, one that uncovers some pretty deep truths about how the universe works, all hidden away inside this strange, beautiful mathematical object.
So, this whole thing really kicks off with a massive question. I mean, think about it. When everything seems to fall apart, when it all descends into chaos, are there still rules? Is there some kind of hidden order, a predictable pattern, even in the most unpredictable things? Well, that's exactly what we're going to explore today.
And to even begin to find that order, we've got to start with a fundamental law of nature. It's kind of like a universal speed limit for chaos. And the crazy thing is, it shows up in the most surprising places you can imagine.
And yeah, a lot of those places, they're fractals. You've totally seen these before, even if you didn't know the name. Think about a snowflake, or the way lightning forks across the sky, or even that weird-looking Romanesco broccoli. They're these beautiful, infinitely complex patterns. And the cool part is, if you zoom in on any little piece, you just see the same basic shape repeating over and over and over again.
Okay, so this isn't just abstract math stuff. This connects directly to the real world. I want you to picture a leaky faucet. At first, right, it's just a steady drip, drip, drip. But then you turn the tap just a tiny bit. Suddenly, it's a 2-beat rhythm. Drip, 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 drip. A little more and it becomes 4 beats, then 8. And pretty soon, it's just a completely chaotic, unpredictable mess of water. That whole doubling pattern, that's what scientists call a period doubling cascade. It's like the classic road that leads straight to chaos.
But here's where it gets really wild. The speed at which that doubling happens, it's governed by a universal number, a constant. It's this number right here, 4.6692, and it's called the Feigenbaum constant. You can think of it as chaos's speed limit. And the mind-blowing part? It doesn't matter if you're looking at a dripping faucet, an electrical circuit, or even a model of animal populations. This exact same number always pops up. It's one of the fundamental rules of the universe.
Okay, so with that universal rule in our back pocket, we can finally turn to our main subject, the Aether Fractal. Now this is like we're stepping into a whole new mathematical world. It's a recently discovered landscape, and just like any uncharted territory, it was filled with unanswered questions.
And of course, the biggest question looming over everything was this. Does that universal speed limit, that Feigenbaum constant we just talked about, does it also apply here? Or is the Aether fractal some strange, exceptional place where the fundamental rules of chaos are just different?
So the researchers, they basically boiled this whole mystery down to 3 core challenges, almost like a checklist. First up, does this thing even have that dripping faucet effect? You know, that road to chaos? Second, if it does, is it governed by the same magic number, that 4.6692? And third, can we actually precisely map out the border, the line between where it's calm and predictable and where it's totally wild and chaotic?
Well, what's so cool about this paper is that they answered all 3 of those questions. So, let's dive into the 5 key discoveries they made that pretty much solved the entire Aether fractal puzzle. And this table here, it just lays out their success perfectly. So first, they did find that dripping faucet effect. Check. That confirmed the universal law was at play. Yep, the Feigenbaum constant holds up, just like they thought. Check. Then, they were able to draw a super precise map of the safe zones, the stable areas. They even figured out how to predict how quickly the chaos grows. And to top it all off, they developed this powerful new thing called a trans-series formula, which is basically just a super-duper precise type of equation that describes the whole shebang.
And look, they didn't just find it, they nailed it. They measured this thing with incredible precision. Get this, their calculations confirmed the Feigenbaum constant to within 0.11%. To put that in perspective, that is like measuring the entire length of a football field and being off by less than the width of your thumb. I mean, that is just a stunning confirmation of how universal this law really is.
Okay, now here's a really subtle but super fascinating detail they uncovered. It turns out the exact point where chaos finally takes over, it's slightly different depending on how you look at it. So if you're just looking along a simple one-dimensional line, chaos kicks in around 14.7666. But if you look at it in the full two-dimensional space, it holds on for just a little longer, until about 14.9048. So you've got the same process, the exact same speed limit, but 2 slightly different finish lines.
So, what does all this mean? Why is solving this specific puzzle such a big deal?
Well, it's because for the very first time, these researchers were able to create a complete mathematical picture of this entire fractal family.
And the tool they use to do it is this powerful, almost magical idea called resurgence. Now, look, it's a really deep mathematical theory, but the core idea is just beautiful. Resurgence gives you a way to connect the simplest, most predictable parts of a system with its most complex, most chaotic parts. It basically proves that they're not separate things at all. They're just two sides of the very same coin.
A great way to think about it is like finding a Rosetta Stone for math. It literally lets you translate between the simple language of stability and the complex language of chaos. Once you have that key, you can finally understand the entire story of the fractal, from its quiet beginning all the way to its chaotic end.
And that is exactly what this paper concludes. I mean, to use their own words, these findings give us a complete resurgent analysis of the Aether Fractal family. This isn't just about finding one more piece of the puzzle. No, this is like finding the picture on the front of the box. They solved it.
And that just leaves us with this one last incredible thought. The Feigenbaum constant was this universal rule hiding in plain sight for so long. This work just confirmed its power in a brand new, undiscovered mathematical world. It really makes you wonder, doesn't it? What other beautiful, universal laws are still out there, just waiting in the hidden corners of mathematics for someone to find them?